Section 12.6 is where we finally get to the true algebra of using logarithms, where we're going to talk about equations. And really, the equations we're going to study here, they break down into 5 categories. And because you might be really good at some categories and you might need to repeat and repeat and repeatedly view the videos for other categories, I'm going to break this into 5 small videos so you can watch each one of them once, and then the ones that you need more practice with you can watch again and again and again without having to waste your time on the other ones. So at first it looks like 4 categories, but it's really 5 because the first category has sort of like 2 different types of situations that fall in there. So overall, there are exponential and logarithmic equations. That means equations that have exponential functions in them, or equations that have logarithmic functions in them. And then the other difference is some equations have whatever the function is showing up on both sides, like you can have exponentials on both sides of the equal sign, or exponentials on only one side of the equal sign. Same thing with logarithms. You can have logarithms on both sides, or logarithms on just a single side. We are going to begin with exponential equations, where the exponentials show up on both sides of the equation. And this type of equation is both the easiest type and the hardest type. It all depends on one key issue that you discover right at the start of the problem. If things go well, the problem's going to be super easy. If things do not go well, the problem is going to be super hard. So this is sort of the no gray area. There's no middle of the road here. There's extremely easy or extremely hard. We'll do the extremely easy first, of course. So take a look at the equation I've got here as an example. It has an exponential function on the left, where the variable shows up as part of the exponent. It has an exponential function on the right, where the variable shows up as part of the exponent. And the thing that makes this equation so easy is because of a key trick you can pull right at the very start. If you think it through carefully, there is a way to rewrite each side of this equation with the same base. So the first step here is to make both sides have the same base. Here's what I mean by that. 27 can be written as 3 to the third. And 81 can be written as 3 to the fourth. Don't forget how to simplify your exponents there. This will give you 3 to the 3x. This will give you 3 to the 4 times 2x minus 3. So that's 8x minus 12. Don't forget you got to go 4 times the 3 also. And if you can do this and get the same base on both sides, then the next step is super trivial. Really, really easy. You just cancel the base. Which would leave you 3x equals 8x minus 12. And you're home free now. You can finish that off very simply. Subtract the 3x, add the 12, divide by the 5, and oh yes, you can indeed get fractions. Don't panic. That's normal in intermediate algebra. That's kind of expected. So this is not a particularly challenging problem. Get the same base on both sides, eliminate the base, and then continue from there normally. Of course, you're probably, some part of you, at least deep down inside perhaps, is thinking, well, wait a sec. What if I couldn't get the same base? That was kind of a lucky coincidence here that both of these could be rewritten in a way where the base was 3. Yeah, that's a very legitimate problem, and that's why these problems are both the easiest and the hardest type. If you can't get the same base, they suddenly shift to being nightmare problems. That'll be in the 5th video that we take a look at, the last one in the list. So we're going to sort of come back to this later on. But for right now, for the easiest type, you should already be pretty successful with ones like this. Get the same base, cancel it out, continue as normal.